Good morning, everyone. First of all, we want to thank you for taking the time out of your busy schedule to join today's webinar. My name is Willie Ortiz, Field Sales Engineer for PNY. Alongside myself, I have my colleagues, Carl Flygare, which is our PNY product manager, Carl Flygare, and we also have Andrew Rink, marketing strategy for AEC industry. So with that being said, guys, can you introduce yourselves and we can start going?
Certainly.
Andrew, go ahead.
Hello. Yep, thanks, Carl. Yeah, hello there, everyone. So my name's Andrew Rink. My thanks to PNY for inviting me. I head up marketing strategy at NVIDIA for the AEC industry. Yeah, really appreciate you taking the time to join us today.
And hello, everyone, as well. My name is Carl Flygare. I'm the Quadro Product Marketing Manager at PNY, and I also welcome your attendance this morning. Please, everyone, let's try and keep the lines as quiet as possible. We've muted folks during the webinar. We'll unmute for Q&A afterwards. That said, I'll turn the baton back to Andrew Rink, and we'll get started.
Great. Excellent. Thanks again. Yeah, okay. Right, well, I wanted to start by briefly touching on a few of the key challenges that are facing the AEC industry. And I don't think it really matters if you're working for a top 20 global architecture company or a mid-size regional firm or as a sole practitioner. These are all areas that pose challenges to completing your work as efficiently and as effectively as possible. For instance, design reviews are often one of the most time-consuming parts of the design process. You've got internal discussions about design issues that can lead to lengthy debates. There are client meetings where at times you simply cannot get a decision from your client on certain aspects of the design. And so it's very rewarding to identify ways to make design reviews more efficient. Remaining in the creative flow, that can be difficult when the software and the hardware tools you work with are slow, forcing you to wait a second or two when you want to see your design from a different angle or to view the modifications that you're making. And today, with increasing adoption of 4K displays, you do need more compute power to refresh all those pixels when you can zoom in. Especially if, like many today, you're working with dual displays. Probably a more annoying example is waiting for the computer to render an image. If you have to go get a coffee or even take a lunch break while your render chugs away, I mean, that's a complete break to the creative flow. And those lost moments add up during the course of a day. So it's not only lost productivity, but there's some level of frustration or impatience, which is a creative distraction. Another challenge to design teams is producing predictable visualizations of their building interiors and exteriors. And by that I mean creating a lifelike rendering, not just a photorealistic image, but an accurate, physically based visualization of how that space or that structure will appear in real life under all sorts of lighting conditions. And the last one I'll touch on is optimizing construction plans. Construction's typically, as you know, a complicated process, a lot of moving parts, a huge number of people often involved with a variety of expertise. But fortunately, there's new technology that even just 3 years ago was not widely available. And it's really bringing some vast improvements to identifying construction problems and logistics challenges before work actually begins.
Hello?
Willie, I think you're moving the slides, right? Thank you. Yeah. So what we're seeing on the technology side in the AEC industry is a convergence among leading-edge technologies that they're often being used together to address the challenges we just reviewed. So advances in photorealism, virtual reality, artificial intelligence and deep learning, as well as mobility, have optimized design workflows by helping keep architects and designers in the creative flow, delivering more accurate visualization of 3D models, like I spoke about, and boosting collaboration among the many people involved in projects. and ultimately enabling efficient design reviews. The recent getting an echo here. Advances in technology are.
Oh, God, that's disturbing.
Yeah. I was.
I'm gonna mute all lines again, and just unmute yourself, just in case you're getting echo from someone.
Right. Yeah. So I was just speaking about some of these advances in technology, powerful GPUs, and that's really leading to more efficient construction workflows. It's also helping map out site logistics in order to make that construction process more efficient, as well as improving safety, which is obviously a critical area of concern in construction. And it's worth mentioning these advanced visualization technologies are transforming content marketing with not only faster creation of marketing assets, but a far more compelling purchase experience. So let's take a look at how these challenges can help small and mid-sized AEC firms to overcome these challenges. Slide. With a double click on a couple of the key ones, slide, related to visualization. Willie? Yeah, and I wanted to start with rendering. Oh, okay, there we go. Thanks. I guess we can move to the next slide too, Willie. So I imagine all of you are familiar with this type of simple rendering, which basically converts your 3D CAD model into a pretty unimaginative depiction of the structure. And perhaps many small firms are still relying on this technique while working on designs or to show models to clients. You can add, some elements like stone or trees, although they tend to be rather one-dimensional. And you can arrange some, oblique, sort of monotone shadows to try and make the image a bit more convincing. But yeah, I think we'd all agree that this kind of rendering really does inhibit effective design communication. Now, slide, if we compare this render to the state-of-the-art ray-traced rendering with GPUs, I think it's fair to say it's like night and day, or whatever simile you prefer. Now, maybe many of you will say, well, this is completely out of reach for me. This would take far too long. I'm not an expert at lighting. Yeah, I can't wait hours for this kind of beauty shot to render. However, slide. With the advent of NVIDIA RTX GPUs and easy-to-use physically based rendering software, this high-quality rendering is no longer out of reach. These new Quadro RTX GPUs integrate frankly, the remarkable advances that NVIDIA made with our new GPU architecture. So, we have to keep in mind that photorealistic rendering is very computationally intensive, and ray tracing even more so. So that's why NVIDIA devised a new type of compute core called an RT core. And that advance, combined with the higher number of CUDA cores in our GPUs, has enabled not only real-time ray tracing with full global illumination, but it delivers the ability to instantly preview these accurate, predictable visualizations of 3D CAD models. So for those of you not entirely familiar with ray tracing calculates the color of pixels by tracing the path that light would take if it were to travel from the eye of the viewer through the virtual 3D scene. So as those light rays traverse the scene, the light may reflect from one object to another, causing reflections, of course, right? It could be blocked by objects, causing shadows, or pass through transparent or semi-transparent objects, causing refractions, right? And all of those interactions are combined to produce the final color of the pixel, which is obviously then displayed on the screen. So in other words, with ray tracing, it's not just a pretty picture of a building interior or exterior. The benefit is what you see on your display is exactly how the final space will look in real life. If you look closely at these side-by-side images, comparing render with RTX ray tracing on and off, the render on the left is very high fidelity, right? But you'll notice the render on the right accurately simulates how the light inside the building creates softer shadows, multi-dimensional softer shadows, right? And lifelike reflections of the metal metal columns. With Quadro RTX, the problem of slow rendering speeds has been solved, but there's the other side of the equation, the software. Like I said earlier, there's been a proliferation of physically based rendering tools that are actually quite easy to use. You've got physically based materials libraries now, where you can simply drag and drop different kinds of realistic stone and wood and glass into your models. So you don't need to create those yourselves. There are HDRI environments in these tools which you can use for all sorts of lighting. So you don't need to be a professional photographer or lighting expert to view your models at any time of the day or night, season of the year, in pretty much any location on the planet. So there's no longer really a need to fall back on that bland monochromatic depiction that we saw earlier. The renders you see here were created using a tool called Enscape, which is an affordable plugin for design software like Revit and SketchUp. It's highly capable for creating real-time renders. It's easy to use, so there's no steep learning curve. And that's just one great tool. There are plenty of others like Twinmotion, V-Ray, which are also widely used in the AEC industry. This next slide is a very short animation to highlight the accuracy of the RTX on render. Note the realistic reflections of the floor and the wall in the polished metal column when RTX is turned on. So that's the realism I'm talking about. That's not an approximation or using techniques to fake how the space should look. Hey, Willie, why don't you run that again? Just back it up and run it again so everyone can have another look and look closely at that column. So that realism means design teams can be truly confident that they're seeing how the materials and the interior lights they select are combined with the natural daylight and the structural design elements and how that space will actually appear when that building is constructed. If we go to the next, help you see why. That one's still finishing there. This next slide, should help you see why predictive results are important. Take a look at this image of a rendered CAD model next to a photo of the final building interior. And, the difference is pretty much indiscernible. And if you go to the next slide, we see the reveal here. So you see the CAD model is actually the one on the right. The objective, of course, is not to fool people with this accuracy, but it's to provide designers with the predictable simulation of the model that I'm speaking about. So, they can immediately see how modifications will appear in real life. And that ability for designers to instantly see the design decisions that they make, whether it's swapping materials or making modifications to windows or electrical lighting, but being able to see the impact of those decisions in a photorealistic environment while they work is very powerful. Willie, why don't you jump back again one so we can sort of compare? Not back here. That's right. So you can sort of have another look at how really indistinguishable this is. And you can imagine changing the color of the hardwood floor or the type of stone for the wall and evaluating that effect in real time in your viewport. That's very, very helpful. You go to the next one. It's really not only useful for design reviews and client presentations, but it's very valuable early in the design process to really sort of help inform your design decision making. And one final point I'd like to make with regards to rendering is the invention of by NVIDIA of AI-accelerated rendering denoising. Essentially, NVIDIA leveraged artificial intelligence to to train the denoiser using tens of thousands of images, which enables it to make an intelligent prediction on what each pixel in that render should look like. And that massively diminishes the time for noiseless images. So you can quickly pan, zoom, rotate your model while you're working and instantly view the render. It might be a little hard to discern in this image, in this still, but the render on the right has the AI denoiser enabled. And if you compare the chairs or let's say the plates between left and right, hopefully you can make out, there's plenty of noise on the left render. And both these images have rendered the same number of frames. So you can see how much faster that AI denoiser resolves it. In fact, performance benchmarks tests are showing that the denoiser accelerates the rendering speed by more than 10 times. And that kind of interactivity can mean a big jump in your productivity when you're visualizing your 3D models on the fly. This AI-enabled denoising capability has already been integrated into software like Chaos V-Ray. So for those of you who don't even produce basic renders today because you think the process is too complicated or you don't have the time, with all this great tech now, you might want to reconsider and give this high-quality rendering a try. Next, so that's enough about rendering. Let's turn our attention to VR. The AEC industry is not especially known for embracing new technology quickly. Next slide, Willie. And the wide availability of affordable VR head-mounted displays, has only really been around for a couple of years. Plus the GPU power required to run them, right? That only came out with NVIDIA's Pascal range VR-ready GPUs. Yet 2/3 of large architecture firms are using VR in their design workflows, according to this survey by the AIA. Perhaps it's not entirely surprising that large companies are leading the way, with their larger resources, but that's still a very high number, 67%. Clearly, those companies have recognized the benefits of VR, and 25% of mid-sized firms have already followed suit. So I think it's reasonable to forecast that VR will become a standard part of the design workflow for just about every successful architect in the next couple of years. So let's take a quick look at some of the key use cases for VR. Design teams are finding this technology helpful because an immersive VR experience really does add a powerful dimension to looking at models that you simply don't get from looking at a computer display. Doing models in VR speeds decision-making, which helps teams obviously meet deadlines on time, and architects and engineers and designers can identify flaws much earlier in the design process to save money and make better design decisions. VR is proving extremely useful, but not only during design, especially useful for their clients or the owner developers they work with during design review, because that immersive experience makes it much more intuitive to see how the built environment will eventually appear. Often clients are not experts in building design, so they have a bit of a hard time viewing 2D drawings or even 3D models on monitors, and truly understanding how that space will look when it's constructed. So that the true scale that we get with VR really helps these non-expert decision makers to intuitively understand what they're looking at. And they experience models in life size and view spaces from every angle. So really they can evaluate design decisions and some proposed modifications with a lot more confidence. Again, that speeds decision making, right? And helps reduce design review cycles, keep projects on track, addressing some of those challenges that we spoke about right about the beginning. So 360 views and walkthroughs in VR, for instance, for facility planning, really do give them confidence to make decisions and speed up that process. another major area of VR adoption is for virtual construction rehearsals. VR helps with planning the construction process and timeline, where contractors can go through step-by-step installation instructions in life size, in true scale, and identify problem areas early on. Equipment placement work can be practiced virtually ahead of actually being on the job site. So this really helps teams identify risks and potential obstacles in advance, which typically saves time and money, as well as improving safety. In fact, one customer told me that by using VR, they had a 60% reduction in the number of design issues during construction. And they decreased the number of RFIs that came up. So they're now saving thousands of hours per project. Similarly, training benefits from VR, allowing workers to practice construction or maintenance work in a realistic, immersive scenario. So that's a more compelling experience, which results in more effective training. And VR is being used in the marketing and sales of all kinds of properties and real estate, from office buildings to high-end apartments to seats at sporting venues. Customers find it beneficial to view their surroundings from all perspectives, walking through the space and looking up and all around. And probably most of you have seen images of virtual tours of high-rise apartments where even the outside environment has been modeled, so people can get a true sense of the view of the city or beachfront, outside that apartment. And the best part's when they look down at the street in VR from the 14th floor and go, "Whoa, that's realistic." I suppose there's still a novelty factor with virtual reality, so it's a nice opportunity for small and mid-sized architecture firms to differentiate themselves in the market. I think it's kind of fascinating to see how the benefits of VR are useful in so many various aspects of the AEC industry. And just like with rendering, there's been a proliferation of easy-to-use software for VR. It's really only a couple of years ago, getting your CAD models into VR was a time-consuming, complicated process. But that's changed now. There are numerous tools in the market, a few of which I call out here, which are simple to use, and some offer one click into VR with direct connection to design software like ArchiCAD or Autodesk Revit. So there's an easy learning curve for these VR plugins, which means pretty much anyone now can easily view their models in VR. Although, of course, you do need a powerful VR-ready GPU to have a smooth, immersive experience with an HMD like the HTC Vive Pro. And I think that brings me to the end of my section. So I'll hand it over to Carl to share some more details about NVIDIA Quadro GPUs and information on selecting the right GPU for your workflow.
We'll be coming back, and Andrew and I will conduct a joint Q&A at the end of the webinar. So I'd like to thank Andrew. I think he gave you an excellent overview. What I'd like to do is dive into a little more detail on the Quadro RTX products that can deliver all of the benefits and workflow enhancements to the AEC community that have been discussed so far. Could we go to the next slide, please? So there are really four fundamental innovations inside what Quadro RTX brings to the table from a hardware perspective. One of them that Andrew mentioned were RT cores, real-time cores that are optimized for ray tracing, which is very, very compute intensive, and in the past was implemented purely in software. By moving the basic heavy lifting over to these RT cores and accelerating them through hardware, NVIDIA brought real-time ray tracing with cinematic photorealistic quality to the market about 5 years sooner than anticipated. Tensor cores, which provide features like AI denoising, but can do all sorts of other things, such as autonomous construction, going in and doing advanced design techniques, really provide the power necessary to accelerate artificial intelligence or deep learning enhanced applications. And tensor cores and these RT cores that I've discussed are both intrinsic and available across every Quadro RTX product. A whole bunch of advanced shading technologies. We could get into the geek weeds really quick. Suffice it to say that these new shading technologies improve VR performance, which is a big plus for AEC. They do things like provide more efficient interaction between the CPU and the GPU. They let you put the detail where you need it in a given scene. They let you work more easily with more elaborate textures. And again, the ISVs that write the software that you'll be using present these through you at a very high-level way through the user interface so you can access these features. Finally, in small and medium-sized firms, you're often doing juggling. You're doing what you went into business to do, which is architecture and doing excellent architecture, but you've got to do the things that need to be done to stay in business. So it's not unusual in small and medium-sized firms to see design work being done alongside of traditional productivity programs. The enhanced CUDA cores, the advanced shaders, allow the GPU and the CPU to more or less work with greater degrees of asynchronous interaction. So they can go off, both of them can go off and do what they're optimized for in parallel with each other, so that you can get extremely high fluid interaction with your design tools, be they BIM, be they rendering, be they VR, while you're also having to deal with things like budgets or scheduling or simple email communications. Next slide, please. It all comes together really with design. And again, architects in a very fundamental, you're not just designing something like a product, you're designing an entire environment. You're designing a setting in which we live out our lives. So the ability to go in and visualize a building or a residence in every photorealistic detail can help you make the informed design decisions Andrew alluded to much earlier, or present those to a client so that they can make an ultimate decision on what direction they'd like you to go. NVIDIA spent a lot of work behind the scenes. Quadro RTX just isn't a graphics card. There are technologies in the real-time ray tracing that we haven't talked about yet. And one of them is materials definition library. Because you folks work with materials in the real world, well, correspondingly, you need the easy ability to work with or have materials be available to you in the digital world. NVIDIA has developed this technology, materials definition libraries. They've open sourced it, provided tools to make it very easy for the folks that provide the raw materials that go into buildings to describe the characteristics of those materials and how they will interact with light. NVIDIA also collaborated with Pixar, who's at the forefront of CGI animation and computer-generated imagery in a bunch of ways, to do something called universal scene description, which handles illumination. And these underlying technologies are the kind of things that with Quadro RTX, developers can work with to bring very simple, very intuitive, very fluid user interfaces that are presented to you during the course of the design workflow. I think another key thing to call out about Quadro RTX is, it's one thing to see a building on a bright, clear, sunny day. What would it look like in the middle of November if it's in the Bay Area, it's kind of foggy, slight amount of drizzle? What would it look like correspondingly in the middle of August with if it's in a high desert environment with a great deal of sunlight, no cloud cover? The ability to visualize not just the building, but the environmental context it's in can be critical to helping you make the kind of design decisions as architects that your clients look to you to do. Next slide, please. Andrew touched about ray tracing, so I won't belabor this slide, but you can see the realism. Next to it, you can see kind of a Iron Man-like model. This is NVIDIA's Project Sol. If we can go to the next slide, I'd like to show you the kind of difference in performance you get with CPU versus Quadro RTX acceleration. And could you click again, Willie? It should go ahead and run the movie. So on the left, we've got an Intel i7-7900, which is not a bad CPU by any means. But you've got Quadro RTX on the right, and it's simply no contest. This is not only using ray tracing, it's using the AI denoising. As Andrew mentioned, that can further accelerate by up to a factor of 10. In fact, I've seen renders that, from ray tracing require several hundred iterations. With the AI denoising kicking in, it can take as few as 10 or 12. So literally the kind of productivity advantage you'd have over a CPU-based system is shown here. Can we go to the next slide? There's a lot going on in VR, as Andrew mentioned, for architects. The key thing to know about Quadro RTX is we're completely agnostic when it comes to virtual reality head-mounted displays. If you like the HTC Vive series of products, you like the HP Reverb or Oculus, your choice. Quadro RTX will work with any of those and has features that will go so far as to actually adapt the way the board renders to match the optics of the lens system in a given HMD. All with the goal of providing the highest possible image quality and most efficient possible use of the GPU. The entire Quadro RTX product line is VR ready, so from the RTX 4000 up to the 5, 6, and 8, if it says RTX as part of the product name, it is ready to deliver professional VR for the AEC community. There are a bunch of technologies that lie under this. Variable rate shading lets you put detail where you most need it. You can also use it to implement a feature called foveated rendering. The fovea is a region of the human eye where your visual acuity is the highest, so that as you're maneuvering around, looking at different parts of a building externally or internally with VR, the highest possible quality will be put in the center of the field of view. You can also have an extremely wide field of view thanks to some other technologies in Quadro RTX that actually approximate those of the human eye-brain system. So no more of the kind of blinkered sensation you get with some VR solutions. Quadro RTX will give you what amounts to the field of view you see in the real world. We're also making it easier to connect VR headsets to the boards. In the past, you had one cable to move sensor data back and forth between the HMD and the computer. A second cable would be used to move graphics, the rendering between the GPU and the head-mounted display. And you'd typically have yet another one to provide power. It was kind of, for lack of a better term, getting a little bit bored. You were pretty much cabled up to do this. Virtual Link provides power, provides information, bidirectional information between the HMD and the graphics card, and the rendered graphics all over a single USB Type-C cable. And we also even offer performance scalability. Dual input VR SLI would allow you, if you're doing something very complex, to assign different Quadro boards to each eye to achieve even higher performance, because the amount of data that has to be generated to do good VR and the very low latency required is extremely challenging. Andrew mentioned tools like Onscape. There are others like Fuser, ShapeSpark, Autodesk Live, Autodesk Revit, Revit Live, that make VR basically a single click away. One thing that's particularly interesting with ShapeSpark is it's really VR intended for browser environments. So you may not have an HMD, but if you've got access to a browser and ShapeSpark, you can do a pretty close approximation of a VR walkthrough, a client walkthrough, although it won't be fully immersive as it would be if you had a head-mounted display. Next slide, please. You folks have to invest wisely in your business, and one of the key points I'd like to make about Quadro RTX is that it is basically future-proofing your design workstations. The technologies that are integrated in RTX did advance the state-of-the-art relative to industry analyst expectations several years before they thought a lot of this stuff would be possible. So the ability to have the RT cores, to drive ultra-high resolution, the latest, high-resolution wide field of view HMDs, get instant interaction with physically accurate and predictable visualization is a key issue, not just now, but over the next, 3 to 5 years. And given the way equipment is depreciated, a 3-year time window is what you want to keep in mind when you choose a graphics card. doing design reviews with VR, catching problems in the design, lowering construction costs, all of those things will make you look better in the eyes of your clients and allow you to interface more seamlessly with your contractors or subcontractors. At the high end, I'm not saying this is necessarily ideal for small and medium-sized firms yet, but a technique called generative design is being used by larger firms. That technology is going to come down the stack, so to speak. Generative design basically uses evolutionary algorithms that let you take a design to a certain point and then pass it over to the computer AI to further optimize that design, be it anything from structural analysis to figuring out the best placement of entries or exits for a venue to allow people to ingress or, exit the venue as quickly as possible. Next slide, please. You also, with Quadro RTX, have support from all of the key independent software vendors that cater to the AEC community. I put 3 of them here. There are certainly others. These are 3 of the larger ones. Autodesk with products like BIM 360, Revit, Revit Live, AutoCAD, Civil 3D, Navisworks is a major player. Bentley with Open Building Designer or Legion Model Builder or Legion Model Builder Simulator and SiteOps and other tools that they offer, again, is another leader in this community. Nemetschek Group offers a vast array of tools. They're behind the Open BIM standard. Their goal is to literally digitize all aspects of AEC workflows. They work with not just their own products, but products developed by other companies, such as ArchiCAD. They offer their own BIMX and BIM Cloud implementations as need scale. The key thing is Quadro is certified by more vendors in the AEC space than any other professional graphics solution. Next slide, please. So we're going to cover the Quadro RTX product line very briefly, starting with the RTX 4000. The point I would like to make about Quadro, though, before we go into specifics, is Quadro is designed for workstations and tuned for professional applications and workflows, the things you do with your computer to make a living. GeForce, excellent products, superb products, but their design center is the PC, and they are optimized and tuned for gaming. That said, let's go to the next slide. The entry product in the RTX range is the RTX 4000. Now, I use the term entry here. It's almost oxymoronic because this is the most powerful single-slot width graphics card available on planet Earth today from any vendor. The single-slot design, the relatively low power requirements make it very easy to deploy in a wide array of system enclosures. You don't need a huge power supply. You have the CUDA cores, you have the Tensor cores for AI, you have the RT cores for real-time ray tracing. You have a very large 8 gigabytes of GDDR6 error correction code optional, the latest in GPU memory technology. If you're doing ray tracing, up to 6 billion rays per second. If you're doing AI work or AI augmentation of some of the tasks, you have up to 57 tensor teraflops to do things like assist that AI denoising. Virtual link support makes it very easy to drive a VR HMD. You also, if you still utilize traditional stereo via an optional 3-pin mini DIN, you can do stereo. One point to make, if you're actually designing a building where you may be using video as part of the installation, this is an excellent board to drive those displays with something we call Quadro Sync 2, choreographing the interaction of multiple displays. Next slide, please. I should mention the street price of the 4000, by the way, is about $889. So if you're thinking, this is a huge, massive outlay, no, it's not. And if you look at it relative to the cost of the software licenses you're using, it's actually quite a great deal because it will, for that less than $900 street price, open up all of the latest and most advanced features in the software tools that you're probably paying significantly more for. The next step up the food chain is the Quadro RTX 5000. This is a dual slot width card. It ups the CUDA core count, it ups the tensor core count, it ups the RT core count, and it also doubles the amount of GPU memory to 16 gigabytes, which allows for larger models or scenes to be rendered with photorealistic results with full GPU acceleration, speed, and performance. Again, DisplayPort supported over Virtual Link. A new feature that comes in here is something called NVLink. If you ever needed to scale performance, NVLink would allow you to drop in another RTX 500 and through the NVLink bridge, treat those two physical cards as one logical entity with near linear performance scaling, and it would also take the amount of GPU memory available for rendering up to 32 gigabytes. Next slide, please. We're getting up into rather rarefied air here with the RTX 6000. The RTX 6000 actually has the most powerful RTX GPU that NVIDIA offers. You see the CUDA core count, tensor core count, RT core counts have all gone up. Memory has gone up to 24 gigabytes of GDDR6, up to 10 billion rays per second, ray tracing, tremendous deep learning, 138.5 tensor teraflops. This card, again, like the 5000, does require auxiliary power, so you're looking at a little more robust chassis, larger power supply, better thermal management in the enclosure. And it can also work with traditional stereo as well as the latest HMDs. Supports NVLink, but actually ups the ante a little by supporting a higher speed implementation. So you could have two of these boards communicating at up to 100 gigabytes per second to allow you to step up the performance of rendering or other compute-intensive tasks. And the card is also fully compatible with Quadro Sync, so if you're doing kind of, kinetic signage, dynamic signage, or, using video as a design element in a public venue of some kind, it can be used to drive those displays, not just help you design the building. Next slide, please.
Hi, Carl. And if I may add in there with NVLink, what allows you to do is double your frame buffer. So in this case, 24 gigabytes of DDR6, you're going to have 48. So if you're working with large data sets, now you're able to load that into video card memory and easily manipulate it and work. And like the previous slide said, it will prevent you for stop your creativity. It will allow you to keep on working and let your creativity flow.
So let's go up to the Uber card, the RTX 8000. It actually uses the same GPU as the RTX 6000. Willie was talking about memory. This card has on it 48 gigabytes of GDDR6. If you use NVLink, that effectively could be doubled to 96 gigabytes. It's safe to say that, this is the kind of rendering that right now is done by the highest-end Hollywood shops. It's probably overkill, quite frankly, for most AEC applications. But again, the key thing is you have a range of products in the RTX family that as you scale your needs, as your business grows, as your creative vision allows you to realize, wider scale, more elaborate, more complex designs, you have a whole family of RTX products that you can pull upon to enhance the capabilities of your workstation. So here, up to 96 gigabytes of memory. Even a state-of-the-art 4K render in Hollywood only takes about 72 gigabytes. So plenty of headroom here with the frame buffer and NVLink for incredibly complex and demanding high-speed rendering. Next slide, please. We did talk about NVLink. NVLink is a bridge that bridges two physical cards together and lets it be treated as one unit, doubling the amount of available memory, scaling the compute performance, the rendering performance, the AI performance. Different motherboards have, in some instances, slightly different slot spacing, so suffice it to say that NVIDIA and PNY offer you different slot configurations based on the slot spacing, and we can work with you to, based on your motherboard or system, recommend the right NVLink bridge if this solution would be of interest to you. You see the performance here, up to 100 gigabytes per second bidirectional, far faster than you could achieve having graphics cards communicate with each other over PCI Express. Next slide, please. Again, we're targeting small to mid-size architecture firms, and you may not have the kind of assets that a larger corporation would have to pull on regarding IT resources. The best way to avoid IT problems is to prevent them from happening in the first place. And the best way to do that is to choose a graphics board that was designed, built, and tested for use with professional AEC applications, which is exactly what Quadro is designed, developed, and tested for, whereas GeForce is tuned for gaming. Gaming can get by with less amounts of memory than the design work you're doing. So the large memory offered in the Quadro boards from 8 gigabytes to 16 to 24 to 48, the ability to support multi-GPUs, NVLink, quad-buffered stereo, gives you the advanced features that allow you to grow the capabilities of your workstation as your design needs, business needs dictate. Another way to avoid issues is simply the gold standard of a Quadro enterprise drivers. They are the world reference for performance and stability with professional applications. And NVIDIA actually offers different types of driver releases. One is what we call an optimal driver for the enterprise, but what it really is a long-life stable driver that ISVs certify their software with, which means if you use an RTX card, choose your ISV application of choice, use the recommended driver, and that configuration is considered certified and will operate with, great performance, high stability, no visual artifacts. NVIDIA Quadro offers ISV certification for over 100 essential professional applications, and all major system builders, from Tier 1 OEMs down to, folks like Dell, Rave Computer comes to mind. All of them test with Quadro. If you do, for some reason, outsource any aspects of IT management, it's important to note that Quadro supports the Windows Management Interface API, so that remote configuration or troubleshooting is doable from these boards, so that should you encounter an issue, you could have somebody remotely troubleshoot the card, determine the possible problem, fix it. This is the kind of capability that's baked into the Quadro driver that simply isn't offered or supported in the corresponding GeForce drivers. With that, let's go ahead and go to our final slide before the Q&A. Cotton Pedersen and Fox is really they're a large firm, of course. They're kind of an industry leader, a thought leader. They've done extremely prestigious products across the entire world. Cobus Bothma, their director of applied research, basically gave us this quote: Turing's real-time ray tracing and AI capabilities will literally change our cities of the future. Turing is the architecture behind Quadro RTX, so the terms are kind of used interchangeably. But this doesn't just need to stay with KPF. As Andrew made very clear in his portion of the presentation, Quadro RTX technology democratizes access to these new techniques, these new tools, this new technology to small and medium AEC firms as well. With that said, let's go to the last slide, and we can open it up for Q&A. One thing I'd like to say before we answer questions is if you think of a question later that you need answered, send us an email at the address you see here, gopny@pny.com, and we will gladly get back to you and answer that question, open up, engage in dialogue with you until we've provided all the information you need.
Muted all lines. So to start the Q&A process, we actually have a few questions as well. I don't have a that you want to put on the.
Okay, I see. Willie, can we figure out where that noise is coming from?
I see it. I'm trying to mute it now.
Okay, thank you. I see a question from Michael Asbell to everyone. We have been using 1080 Ti's for our workflows. What would be the best Quadro replacement? Again, it depends on the kind of it depends on the cost of the card you're looking at. RTX technology starts out at street price of around $900 with the RTX 4000. The RTX 5000 comes in at about $2,300 street price. I'd take a close look at the Quadro RTX 4000 or 5000.
Yeah, I think that makes sense. I noticed Michael's question because he earlier said that he's using a number of Autodesk software tools, including AutoCAD and Revit and Max. So obviously, rendering is part of the workflow there. And the new rendering engine in 3ds Max, it came with Autodesk acquisition of Arnold, and that supports RTX technology. So one of the things I wanted to mention, just to perhaps add a couple of points to Carl's very comprehensive explanation of the difference between Quadro and our GeForce cards. And that one of them, the point I wanted to embellish a little bit is about the ISV certifications, just to help folks understand, what that actually means. So the Quadro part of our business has very close relationships with Autodesk and all of the CAD ISVs, and we devote a lot of software engineering resources to working with our ISV partners like Autodesk and the others to ensure the stability and the performance benefits, and access to professional CAD advanced features like FSAA, full scene anti-aliasing, right? OIT, order independent transparency, AO, ambient occlusion, all those kind of things. They only work well with Quadro because we tune our drivers to make sure we're taking full advantage of those sort of advanced visualization techniques. So, apart from all the other differences, and it's also worth pointing out, if you do come across a bug when you're working with the certified tools, or a crash, obviously with Quadro, you're going to get full support. We will track that down, fix the bug, and you don't get those crashes. So obviously, if your work is mission critical, you kind of want to rely on that reliability.
And Andrew, that ties into another question I see here. So where do the NVIDIA Studio drivers fall here? They're promoting RTX cards for designers, not necessarily Quadros. A point I'd like to make about the NVIDIA Studio drivers is, yes, NVIDIA did go in and do some work, some tuning, some optimizations for non-gaming applications. But what Andrew just mentioned, the escalation process behind the Quadro driver simply isn't available with the NVIDIA Studio drivers. If NVIDIA or PNY are made aware of a bug in a Quadro driver from you good folks, we have the ability to directly enter that bug into NVIDIA's software engineering team. And NVIDIA actually employs more software engineers than they do hardware engineers. We can enter the bug, we can work to get it reproduced, we can track the progress towards eliminating it, and then notify you when there's a driver drop that resolves the issue. Even though NVIDIA is working with the Studio drivers to a certain extent, they simply don't offer that kind of closed-loop end-to-end, identify the problem, reproduce the problem, solve the problem, do another driver release that you will see with the Quadro drivers. So Studio drivers are nice, but they still come nowhere near the Quadro drivers in terms of support, and they still don't offer the things like, remote administration troubleshooting that can be very important in a business environment.
Hey, Carl, I'm going to mute all the lines, and if anybody wants to ask a question, just star 6 to unmute yourselves. This way we kind of minimize the background noise.
Another question I see here, do you know if Unreal Engine has support for Quadro cards? The answer is absolutely yes. And in fact, Unreal and Unity and some other game engines as well are becoming widely used in AEC to do, virtual client walkthroughs or, sales and marketing of commercial, architecture and development projects. So they have been working with the AEC community and the AEC tool providers to allow your CAD drawings or BIM files to be imported and rendered using the game engines that were originally developed for gaming use. So the answer to that question is yes.
I might add, because we were expecting much of the audience will be coming from small and mid-sized firms who may not have a visualization expert. Real-time, rendering tools like Unreal Engine. So Epic Games, who of course own Unreal Engine, earlier this year acquired Twinmotion. That was one of the rendering software tools that I mentioned during my segment of the presentation. And that is an easy-to-use tool, and there's a lot of development work that's going on. Well, first of all, I would say. Well, actually, I think you already said this, Carl, but yeah, so Unreal Engine 4.22 does have support for RTX in it, so it does take full advantage of RT cores and, all the goodness that comes with that.
Andrew, there's a question. They have been using 1080 Ti's in the workflow. What would be the best Quadro replacement for their environment?
Yeah, I mean, I think we answered that a moment ago. We're talking about, you probably, I'm assuming that you're doing rendering or maybe VR work, right? So you'll want to get an RTX 4000 if you're talking about on the desktop side. I know there was a question earlier about mobiles, and there is a full range of mobile RTX Quadro RTX GPUs available from many of the mobile workstation OEMs. But yeah, on the desktop side, it'd be the RTX 4000, I would say.
And also, they would like to know the best solution for AutoCAD and 8K video editing.
Yeah, 8K. Well, and that's pushing the boundaries. But certainly, these RTX GPUs can handle that sort of thing. It depends, I suppose, on the size of your scenes, right? Your models, how much GPU memory you need. The RTX 4000 has 8 gigabytes. As Carl mentioned, it's so-called the entry level. I mean, it's a very powerful GPU. So 8 gigabytes is a good amount of VRAM. But as you go up to 5,000, I think you saw the specs. So yeah, depending on the amount of how large your scenes and models are, you want to have the larger memory.
They also want to know if there's a difference between GeForce CUDA cores and Quadro CUDA cores, and they love the stability of Quadro boards, but if we can say if there's the difference between the two.
Yeah, CUDA cores are CUDA cores. Yeah, I think the really critical thing to emphasize from the points that Carl was making is that GeForce are designed for PCs, right? And they're really tuned for gaming. If you're working with enterprise workflows with CAD tools, you want that build quality of Quadro, where Quadro is very solidly built. They've got rugged heat sinks and connectors, so it really does ensure that mission critical reliability. That's a big. They're designed for workstations. It's a different kind of a workflow, isn't it, between a PC and a workstation? Different sort of uses. There was another question I was just catching here.
Yeah, let me do one really quickly. Do these have the ability to run in an external GPU enclosure? The answer is yes, they do. So if you're thinking of wanting to use a mobile system and you've got Thunderbolt 3 specifically, all the popular eGPU enclosures should work with Quadro.
And I know we're running out of time, but there's one more question just to answer quickly because it's an easy one. Is there a limit to how many cards you can bridge together? So NVLink connects 2 GPUs, so that's the limit with NVLink. However, you can have multi-GPU configurations in workstations up to 3 GPUs. And then, of course, we do have RTX server, so that's where you can get 8 GPUs into a chassis. That starts to get a little beyond the workstation, but but the most you're going to link together are 2. But
I also want to see if you can touch on AI and benefits with Quadro with AI.
Yeah, Quadro.
Well,
so
AI
Quadro
is, Andrew Ng, who's the former chief scientist at Baidu, basically had a very memorable quote. He basically said AI is the new electricity. I mean, it's kind of hard to say just how far-reaching AI will be across, the world. But the fact of the matter is, it is touching every major industry on the planet today. From an AEC perspective, we've talked about the benefits of AI denoising. Generative design, which is being used today by large firms, will migrate down to small and medium-sized firms. Really does take a design and optimize it beyond the abilities of a human designer to do. It also, from an AEC point of view, can produce a surprisingly new aesthetic that in many ways almost seems biological as opposed to industrial in its overall look. AI also can provide autonomy on the construction site. One of the slides we actually showed an autonomous robot that lays bricks, and it can lay them, in any intricate pattern desired with exacting precision. So expect to see more and more automation. Expect to see AI show up in smarter buildings. As we keep looking to make buildings more energy efficient, more sustainable. More and more systems will become actively digitally monitored, and trained DNNs could go in and make sure the HVAC system is running just where it's required as opposed to running over capacity, under capacity, that sort of thing. AI can also be used to, model, again, another example of generative design, the motion of crowds into or out of a building or around an urban setting. AI could also potentially be used on the marketing side of it. If you're trying to go in, you've got a design, you're looking for clients that would be optimally interested in it. You could literally think of implementing technology similar to what streaming video services do today, where based on this portfolio of TV shows or movies that you've watched X, Y, or Z, here's what I think you're interested in. Well, you're very good at designing, say, hospitals, and particularly surgical rooms within hospitals. What could you potentially go out and market that? So it won't just be the design workflow, but it could also help how you present your services and your areas of expertise to your clients.
Yeah, one critical point to add, how AI, Quadro RTX, of course, integrates tensor cores, and tensor cores are the hardware that accelerates AI workflows.
Yeah, they do something called the fuse, multiply, and accumulate operation, which is kind of the mathematical primitive that underlies deep neural networks, which today are the best means of achieving, vertical domain-specific AI and machine learning. And they run far faster on GPUs than they can possibly run on CPUs.
I guess that wraps it up, right, Carl and Willie?
Yeah. Everyone, I would like to thank Andrew again for his participation. It's wonderful to have, the head guy, so to speak, in NVIDIA for AEC with us this morning and benefit from his insights. I hope I've been able to contribute as well. Again, if you have follow-on questions, go pny@pny.com. We'll engage with you and get them answered. That said, thank you, everyone. Have a wonderful day, and enjoy if you're in the U.S., enjoy the upcoming Labor Day holiday.
Thanks, everyone.